All right, today we're cracking open the legendary Gang of Four book to talk about one of its most important patterns. It's a creational pattern, and it elegantly solves a problem that I absolutely guarantee you've run into yourself: the factory method.
So, let's kick things off with a problem that every single developer faces. It's one of those classic situations that seems totally simple at first, but can very quickly spiral into a real maintenance nightmare.
So, picture this. Your code needs to create an object. Simple enough, right? You write a clean, straightforward conditional. If some condition is true, you create object A. It works, it's direct, and honestly, it seems completely harmless.
But then, you know what happens next. The inevitable. A new requirement comes in. Now you need to support a different kind of object, object B. So you just add an else if. It's a tiny change, but this is where the trouble really begins. The code that uses these objects is now directly tied to the specific details of both of these classes.
And let's be honest, it never stops at just one else if, does it? Pretty soon you need another type and then another. And that simple, clean conditional has just ballooned into this fragile, complicated mess of logic. Every single time you need a new object type, you have to go back and change this core piece of code, making your whole system more and more rigid.
Now, the Gang of Four has a name for this problem: tight coupling. And they describe it perfectly. They say it leads to these monolithic systems that are a dense mass that's hard to learn, port, and maintain. Basically, the part of your code that just needs an object gets all tangled up with the gritty details of how every single type of object is actually built.
So how do we break free from this tangled up mess? Well, this brings us to the absolutely brilliant idea at the very heart of the factory method pattern.
The whole concept here is really a powerful shift in responsibility. What if our client code didn't need to know how to build the object at all? What if it could just raise its hand and say, hey, I need a product, and then just delegate that messy creation business to some other component that specializes in it?
And here it is, the formal definition, straight from the book. The key phrases you really want to zero in on here are define an interface for creating and let subclasses decide. So, in plain English, we're creating a contract for how to ask for an object, but we're letting other parts of our code decide which specific object they're going to build in response.
Okay, so let's dive into the structure a little bit and meet the key players in this pattern. I promise, once you see who's who, it all just clicks into place. This diagram, right from the book, shows the four key players. Let's take a look. Over on the left, we've got what's called the creator hierarchy. That's who is responsible for asking for the objects. And on the right, we have the product hierarchy. These are the actual objects that get created. The factory method is that crucial link that connects the two.
Let's break this down with the book's classic example to make it real. The product, that's a generic idea, an interface, like a document. The concrete product is a specific version, like my document. Then you have the creator, which could be our main application class. It declares the factory method, maybe called createDocument. And finally, the concrete creator, like my application, is the one that actually implements that method to return a brand new my document.
Okay, so we've met the whole cast. Now let's see how they all work together to actually create an object. This is where you're going to really see the power of decoupling in action.
The flow is just beautiful in its simplicity. Our client code, which is working with a My Application object, just calls createDocument. That's it. It has no idea that a My document is actually being made. It doesn't care. It just gets back an object that fits the generic document interface, all ready to go. The client is completely shielded from all those nitty-gritty implementation details.
So, like any tool, it's not enough to know how the factory method works. You've got to know when to use it. So let's weigh the pros and cons.
The biggest win, by far, is that you decouple your code. It makes everything incredibly flexible. This is a perfect example of the open/closed principle at work. Your code is open to extension because you can add new factories, but it's closed to modification because you never have to touch that existing client code again. Now, the main downside is that it can add a bit of complexity. You might have to create a whole new class just to create one new type of object.
And hey, this isn't just some academic theory. This pattern is seriously battle-tested. The authors point out that you can find factory methods all over major toolkits and frameworks. We're talking systems like MacApp and ET++, the Unidraw graphical editor, and even the pioneering Smalltalk 80 MVC framework. This is a real-world solution to a real-world problem.
All right, let's bring it all home and quickly recap the most important things to remember about the factory method pattern. So, to sum it all up, the factory method is all about one thing: delegating object creation to subclasses. That's the secret sauce. It's the key to decoupling your code and making it way easier to extend down the road. The simple rule of thumb from the book is to reach for this pattern whenever a class can't know ahead of time which specific objects it's going to need to create.
So the next time you're coding, and you're about to add another else if to handle creating a new object, I want you to just pause for a second. Ask yourself, could a factory make this better? The factory method isn't just a pattern, it's really a mindset that leads to more robust, more flexible, and way more maintainable software. Thanks for tuning in.